It is suggested that the height in metres of the tide above the mean sea level on the 1st of January at Warmung is given approximately by the following rule. So HT is equal to 2 sine pi on 6t plus 3, where t is the number of hours after midnight. So these things are really important in worded questions because it'll make sure that we actually answer our question correctly. So in part A, we're asked to draw the graph here. So let's get all the information before we start sketching and setting up our axes. So what do we know? It's a sine graph, so it will have an amplitude, and the amplitude here is 2. All right, that means that y is between -2 and +2. But look, we have a y translation, so we're going to move up 3. Okay, so y is actually now between +1 and 5, where my mean value, my middle value, is at 2. All right, what else can I get from the equation? Well, I know that the period here is 2 pi on n, and my n value is pi on 6, which means that it is 2 pi on 1 times by 6 on pi. The pi's cancel, so I have a period of 12, or 12 hours, if you like. Is there anything else that I can get from that graph? Well, I know the trend. It's a positive, so I'm going to go up and down and back up again. And so we're just about ready now to draw the scale on our graph, and we know that we have to do it between 0 and 24 hours. So on my x-axis, I've gone up in 3s all the way up to 21. I've labelled that t, and it's in hours. And on my vertical axis, I just needed to go up in 1s, because that's the height, and my height is between 1 and 5, and that's in metres. Now we know that the graph has been moved up 3 places, which means my middle has been moved up 3, and therefore I'm going to put a line there so that I know that that's where my graph is going to oscillate. And it's a very light line. If you're going to do one, make sure you do it very lightly, because it's not really part of your graph. All right, the next thing we know that is that our graph is going to start at 1. So I'm going to draw another little dotted line there, so that these are now my guidelines. Remember, guidelines help you to sketch the graph perfectly. So there's my guidelines there, and it goes up to 5, and so I've got some more guidelines along here. Now I know that one full cycle will take 12, so there's one full cycle, and you can see the box happening there. That's where I've got to draw one full cycle of my graph inside it. So how does it go? All right, we know that it's a sine graph, so we are going to start in the middle, goes through the middle, ends up in the middle, and it reaches its highest point in the first half, reaches its lowest point in the second half. So there is one full cycle of the sine graph, and of course I need to extend that now because I need to go for 24 hours. So again, middle, middle, goes up in the middle, goes down in the middle, and there is another cycle of the sine graph. It should be a nice smooth graph, and of course you're going to do better on your paper with a pencil. So that's what our graph looks like. We now need to answer some of the questions. Now some of the questions we can actually answer from just looking at the graph. Part B says, when was high tide? So if we look back to our graph, we can see high tide was at t equal to 3 and t equal to 15. Now, of course, that doesn't answer the question because we know that t is the hours after midnight on the 1st of January. So when was the actual high tide? It was at 3 a.m. because that is after midnight, and then 15 would be 3 p.m. on the 1st of January. Okay, let's be very specific there. What was the height of the high tide? Well, we're looking at our graph again here, and you can see that the highest our tide goes to is 5 meters. If I was going to do that working out, I would have to put it into the equation and say 5 is equal to 2 sine pi on 6t plus 3. And then I would have to go and solve that like I've been doing with my equations. So if it's not readable from the graph, we should be able to still work it out. What was the height of the tide at 8 a.m.? Now this one does need to go into your calculator. So we know that 8 a.m. is when t is equal to 8. a.m. is just 8 after midnight, and so h of 8 is what we want. We want the height at t equal to 8, and it goes 2 sine pi on 6 times by 8 plus 3. And when we put that into our calculator, we get 1.27 meters. So at t equal to 8, we get the height of the tide equal to 1.28. Go back and have a look and see whether that's right. A boat can only cross the harbour bar when the tide is at least 1 metre above the mean sea level. Remember, our mean sea level is 3. So 1 metre above would be there. So there, 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 and there. Anything below that pink line, the boat cannot cross into the harbour. So we're looking at an interval, if you like, between those 2 points and those 2 points. So how do I actually go about doing that? Well, I know that my height is equal to 4, and I want to find the t values. So I'm going to substitute that into my equation, and I get 4 is equal to 2 sine pi on 6 t plus 3. All right, let's bring that 3 across. 4 take away 3 is 1 divided by 2. So a half is equal to sine pi on 6 t. Now, remember, I can solve any equation, sine, cos or tan. And what do I know here? I know that sine is positive. All right, I know that I'm going around 2 rotations, so I'm going to go around 2 rotations. So where is sine positive? There and there on the first time around, and there on the second time round. Let's get our basic angle, sine theta. So don't worry about all the complicated angles, it's just sine theta equal to a half. So therefore theta is equal to pi on 6. Now, is that a solution that I'm going to take? Yes, it is. But remember, I don't have theta, I have pi on 6t is equal to, my first solution is pi on 6. My next solution is in the second quadrant, so it's pi minus pi on 6. So pi minus 6 minus 1 is 5 pi on 6, and then I'm going to go around 2 pi from each of them. 2 pi being 12 pi on 6. So pi plus 12 is 13 pi on 6. And then my last one, 5 plus 12 is 17 pi on 6. Now I want to get t. So I'm going to divide by pi on 6 or times by 6 on pi. So let's work that out. Pi on 6, and we'll do the first one together. You get pi on 6 times by 6 on pi. Cancel, cancel. So you end up with 1. Same thing for 5 pi on 6, you get 5, and then 13, and then 17. So when can that boat enter the harbour? Between 1 and 5, which is 1 a.m. and 5 a.m. So between 1 a.m. and 5 a.m. and 13 to 17 is between 1 p.m. and 5 p.m. So that is how we would do it manually. You could probably do that on the calculator as well, as long as you show some development of the question, because most of these worded questions are technology questions.